Okay. Morning, everybody. How we all doing? I'm going to grab this door real quick. Just going to grab this. I'm going to make sure I actually have any amount of volume. Sad we don't have a Calgary cohort to let us know when things are... Do we not have a Calgary cohort? Do we have a Calgary? No, we don't have a Calgary cohort. Final answer. Yeah. So midterms, huh? Huh? How's that going? Who are the teams? Fair enough. You just said, okay, fair enough. For nerf. Okay. So, I guess yesterday was Wednesday. So you had the kickoff. Some of you may have not started coding yet. Apologies for that. Hi. Who has started coding? Who started to put together like ERDs and started kind of anything? All right, just wondering. Did anyone have their migrations and seeds started? No? Okay. I may have to take somebody else's code for that then. All right. So how is the who can tell me which just somebody just pipe up and tell me which app you took off the list? Got some resource wall? How many teams are doing resource wall? All but one. What's the other one doing? Restaurant. Yeah. That's a pretty common one. Okay. Cool. Well, what we're going to talk about today is this is one of those lectures where I'm not technically going to teach you how to do anything new. I'm going to teach you a pattern for doing things you've already done, but doing them better, doing them in a way that's a little more clear what's going on, that sort of thing. So we're going to be kind of talking about some control flow stuff and some stuff that we're going to use to deal with async code. So the title of today's lecture is, I've made some promises. I've made some errors. We're going to be covering promises and errors. So what are errors? They are a synchronous method of ending function execution. So this is synchronous code. We're going to get into async in a bit. But that represents that a process could not continue. This is something this is a way of ending a function that says, it doesn't be like, oh, I'm done, ha ha ha. It's more like, yeah, I couldn't. I'm going to let you know I couldn't do anything. This went terribly wrong, and here's exactly why, right? If uncaught, it will halt the entire stack. So another thing about errors is that they're a way of stopping execution that will stop the entire stack. For instance, you guys are used to early return, you know? How many of you have written something like this? Like, I don't know, for instance, if you were, let's say you were making a URL shortener and you were implementing authentication and you wanted to find a certain user with a certain email. Well, you would kind of go through the list until you found that, right? And then you would stop. Right? You wouldn't have to search through the rest of the items if you already know that you found what you're looking for. And that's an early return, sometimes referred to as a short circuit. You know, we just kind of like stop here and then go. So take a look at this example. We have an outer function, we have an inner function. We call the outer function does outer A, inner FN, outer B. So let's find out. I want you guys to tell me what you expect to be the first console log here. Can you guys see that? You can get a bit closer if you can. What's going to be the first thing that we see on the console? Outer A. Cool. Yeah. Uh, okay, so what's next? Hmm? See, what actually is that going to happen? It's going to outer A. It's going to do the inner function, so it's going to get to inner A, and then inner B, and then outer B, right? Okay, so what happens if I put a return here? Let's run this again. What's the first thing I'm going to get to? Outer A, right, right. And then it runs the inner FN, so what is the next thing I get to? Inner A. And then outer B, right? It skips over inner B. It stops the execution of inner FN, but it continues the execution of outer FN, right? So now we're going to throw an error. And this is the syntax for throwing an error. And what's going to happen is we're going to get to outer A. We're going to go to inner FN. And we're going to do inner A. We're going to get to throw new error, oh no. And that's it. What ends up happening is the way that returns stop the execution of inner FN, return is also going to stop the execution of outer FN. The way I like to think of this is you can imagine you're on the SkyTrain, and let's say you're going from the end of Coquitlam and going to Vancouver. So you can, yeah, I chose my SkyTrain route. I know, I'm that selfish. You can go from Coquitlam. So you start at the very beginning, which is Lafarge, Lake Lafarge? Lafarge Lake? Yeah. Lake, the words Lake and Lafarge are in there in either of those orders. I thought it was Lafarge Lake Douglas, yeah. So you start there, and you kind of keep on hitting each. You hit Lincoln, you hit Coquitlam Central, Coquitlam Center, I should say. And like you keep on going through all the stops, right? So you can think of like each line of this as stops that you go on. And an early return is just like basically being like, hey, I'm at my stop. I don't have to go all the way to the end. I'm where I'm supposed to be. That's cool. An exception is a little bit like you're in between stops, and you're like, I don't want this train to go anymore, so you drop a grenade, right? And yes, you indeed end your journey while also destroying the train and possibly the track, right? Which is, so it should strike you as odd that this language has a feature that will brick your app. Think about that for a moment. Like, I want to stop this thing. I return. I want to really stop it. Then we're going to destroy the whole thing, right? Kind of crazy. So, excuse me. So the thing is that this mechanism isn't all that helpful unless there's some way of kind of stopping it at certain levels. So what we can do is we can basically put a try catch around this. And a try catch is a little bit like if we have something and we're not sure if it's going to throw an exception or not, putting it in that try catch is like we have an explosive, a device that may or may not be explosive, and we put it in like a big solid steel and concrete box, right? And then we sort of like let it run and close the hatch. And after a little while, we just kind of like make the seeds. And there's a little bit of smoke, and be like, okay, cool, it didn't work. Why didn't it work? Or it might just be fine. It might just go through its whole thing, and then we kind of just open the box and it's okay. So try catch is that process. So if we start here, what's going to happen is we're going to try to do the outer FN. We're going to hit outer A. We're going to hit inner A, right? And then it's going to throw an error, oh no. But this try catch is going to catch that error. And now we can do with that message what we wanted to, like, yo, error message, but we have not actually stopped our application from running. Our application is running just fine. We just made sure that we could actually run this. So if I move that try into the outer function, so I'm writing the outer function, I know my inner function might error out, might throw an exception, as we sometimes call it. So we can actually move that try catch around the inner fn. So let's try to figure out what's going to happen here. Let's try to figure out the sequence of console logs. What's the first one that's going to run here? Running outer fn. So what's the first? Can I zoom in on this anymore? Just need to zoom in a little bit. There we go. So running outer fn. What's the first console log we get to? Outer A. All right. Now it's going to try inner fn. So what's the next console log we're going to get into? Inner A, that's right. And then, of course, it throws the error, right? Which means the execution of inner A is done. And that means that our try-catch activates. So what's the next thing we're going to see on the console? Yo, no. That's right. And then, what's the next one we're going to see? Outer B, right? Because the functioning of outer B is still running. We didn't like blow up that bit. We kind of, so instead of encasing the entire train in a big box, we just put a big box inside the train, but around the thing. If that helps. That analogy works until you construct a gigantic box to put a train in. Okay. And that's kind of that's how exceptions work in procedural languages that have like kind of that set of I'm executing a set of instructions. This is how that works. This is a common enough mechanism in tons of languages. Ruby is going to have it. I think they call it raise. Java, C#, they have it. With Java, it's an interesting take on this, is that when you define a method, you define what exceptions it might throw. That's part of the definition, which is pretty cool. Okay. All right, and that's a bit about exceptions. It may be worth kind of just running them in like a Python tutor or something just to get used to them. But now we're going to talk about the real meat of this, the thing that like the one big struggle, one of the biggest struggles in computing in general. Like we're always trying to find better ways to do this thing. And that is, well, we call it in JavaScript, we call it async code, asynchronous code. You've already been dealing with async code quite a bit without realizing it, because you've had Ajax and you've had a few other things. So synchronous code is code that's run one step at a time in order in one unbroken process, usually with all the same memory, right? Var a equals 3, a plus equals 1, for var I equals a, a is greater than or equal to 0, I minus minus, do a thing, right? It's very much step, 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 step. Whereas asynchronous code is kind of broken up over different processes, and there might be a few reasons for that. So like your week 1 code was always very synchronous. It was like I do this, and then I do this, and I do this, and I do this. It's very sequential, right? Asynchronous code doesn't have that same, like, you can't necessarily trust the sequence the same, or you may have to break the sequence up in different parts. So some things that may cause us to have asynchronous code might be animations, or a delay, or we might have to talk to other systems. This is the #1 cause of async code. We might want to be able to take a large operation and break it up into a series of smaller operations. We may want to take a bunch of small operations and actually batch them together. So we can use async methods to take something and sort of like, you know, basically if there is a right size of computational effort to take, you can take something that's like too large or too small and put it into those right sizes, whether that's breaking it up or batching it. That is a bit advanced, but that is something I find myself doing, where I have something that's like a little too big. I find ways to use asynchrony to sort of like either break it up or put it on a different process. So yeah. Okay. So here's an example of talking to another system, right? And here's kind of how Node approaches this. So imagine we have Node and we have some database somewhere. Yeah, I made these on a whiteboard in one of the other rooms, which is why it's a bit off-white. So Node makes a DB request, right? And the database handles that request. Okay. And the DB makes a response, figures out which way it's going to respond to this request, right? Some sort of like maybe it does a query, maybe it does something. But then it basically sends that response back to Node, and then it's up to Node to handle it, right? So on the DB, this is one little synchronous. This can be easily a synchronous process, right? Oh, I get a request, I do the thing, I go through my options, I handle it, I send it right back. Well, if we did this on the Node side, made the request and handled the response, and we made that one big process, it kind of looks like this. You know, I have some function somewhere called makeDBRequest. Just some function somewhere. Part of some library, some API, some something, right? And I would say const result equals makeDBRequest query. And then I would do something with that, right? Like I would want to perform some side effect. I would want to execute some instructions. I would want to display it on a screen or display it in a console log or send it as the response to an HTTP request or something, right? I want to perform something. I want to consume that data somehow, which makes sense. And this is the synchronous version of that. I make the request, I get a result, I do something with the result. Right? But what ends up happening is if we did all our code that way, that green section there represents wasted time. It represents all that time that we could, like, that would be the thread just waiting. And since Node and pretty much all JavaScript runtimes are single-threaded, which means that basically they can't multitask. They can only ever do one thing at a time. That'd be like me asking Chris to go get me something from the kitchen and then just kind of staring at his spot, just kind of waiting. I can't do anything. Anyone else has a question? I'm like, shh, waiting for a thing. I can't do anything. All right. That's what we'd call a blocking I/O. And one of the things about Node and one of the things about browser JavaScript is that it is non-blocking. So what we do is instead of making this one big request on the Node side, we split it up into two processes. And what happens then is that like I can be like, hey, can you grab something? You're like, cool. And then I just sort of like am able to do something else. I'm able to answer questions. I'm able to make stupid jokes. I'm able to basically do those two things. That's just all I do. Right? I'm able to do whatever I want in here, and I can start filling that space with a bunch of tasks. And maybe I'm even working on a task when he comes back, and I'm just like, he's like, oh man, here's your coffee or whatever. And I'm like, okay, thanks. I will drink that in a second. I appreciate it. Thanks. And I finish whatever it was I was doing, and then I start that other task. Make sense? So this is async code. This is now we have broken this up over processes. So if we were to take our synchronous code here and make it async, well, we'd have to have some version of make DB requests that actually took in a callback, right? And then, so we'd have to have our library to deal with DB requests has to take a callback. And then what we can do is basically take the stuff we were doing, console log, I'm consuming a result, and just wrap that in a function to which we pass results. So now, instead of getting a result from the main body, it's going to get it here. If that makes sense. It's going to get it as a parameter to a function. There is a really stupid joke that is really, I still find it helpful, therefore I still say it, which is functional programming doesn't have state, pass it on. As in, the state is always passed as a parameter to a function. I know, it's bad, it helps you remember things. I'm okay with that. So rather than just have the state kind of lying around, we're going to pass it as an argument. And then we're going to do something with it, right? So then we do is, we just pass that callback to our makeDB request query, and then we get rid of that const result equals because we don't care anymore, right? Now, I think that what I've just described takes you all up to week 1, day 4. Like at this point, this is just hammering home the pattern that you've been using many times, right? We're all kind of comfortable with. So you guys are like, no, this is new, this is good. I'm like, okay. I'm glad that you had your moment. But this is the basic idea of callbacks, is that we start from this synchronous version and we end up here. It's all the same code, just kind of packaged differently, right? Okay, so the handle result function will be called when the async process is done and with the result of that process. So now that we're reasoning about asynchrony, I am going to introduce the kind of like when and with what concept. Those are going to be really important. We're going to talk more and more about that. So handle result will be called when the async process is done, and it will be called with the result of that process. Simple enough. Okay. I know, I was so pleased with myself when I came up with this slide. I know this doesn't help you, but this makes me happy. Okay, so promises are the oh, Abhi's look on his face. He's just like, what? All right. Promises are the reification of expectation. The word reification means to make something into a thing, right? It means to take some sort of process or concept and turn it into a thing. So promises just take the concept of expectation and make a thing out of it. Yeah, you're right. That's not very helpful. We'll talk about it in a moment. This'll help you. Promises are to time what arrays are to space. Does that not help? Is that not any clearer? Basically, with arrays are they're the ability that, like, we only have one value. An array is just one value, but within it, it's hiding a bunch of values, right? So it's basically the reification of, like, we want to hide an unknown number of things in a box. We want to you know, like a Dungeons and Dragons bag of holding that we can use. That's like an infinite bag of holding. Like, you know, just I want to be able to keep pulling values out of that. It is a little disturbing to watch. I'll move on to the next one. Right? But that's the idea behind an array, is that we want to be able to keep pulling values out of it and keep on doing stuff with it. And while we're at it, we also want to be able to compose arrays and transform arrays in some way, right? We might want to have an array where we have a bunch of, like, student objects. We might just want their names. We might have an array of things, and we just want to get the odd numbers out of it. We just only want the ones that have an odd number or have over a certain amount or under a certain amount, right? So we can take one array and transform it into a different array that meets our needs better. We're all following? Okay, so promises are these really simple state machines. And a state machine is just a machine that's in a certain state. You know, when I say it out loud, it just wasn't even worth saying. The idea is that there's three states that it could have. A promise can be pending, and that just means, like, we haven't done anything yet. It can go to being resolved. Yeah, that did not turn out clearly at all on this screen. That's bad lighting in this room. So it goes to being, it can either go to being resolved, which means that it has resolved with some value, or it is rejected with some error. But basically, when it's pending, it has no payload. When it either resolves or rejects, then we have a payload of some sort, whether that's a value or a something. So what I'm going to do is I'm just going to kind of show the code for how we would turn this into a promisey version, right? So we have make DB request, takes in a query, takes in a callback. And in fact, I'm going to expand this handle result a bit to be the node style callback, the error first callback. You guys have seen a few of these, right? Error results, something, some little. This looks vaguely familiar. Anyone? So we say if there's an error. By the way, where am I? Let me check to see where I am on my slides. I'm trying to see if I put a coffee somewhere in here. Yes, I did. Okay, cool. Sorry. Just making sure it was in my spot. Okay, so we're going to expand this to this a little bit, right? Because we want to be able to handle errors. If we're talking to another system, things could go wrong. We could have a it's not you, it's me situation. We could have a it's not me, it's you situation. We have a situation where it's like, hey, we're trying to work with someone, but maybe that other thing doesn't quite work the way we want it to. So we want to handle errors as well. So, but what we could do is refactor this. So maybe we have make DB request where instead of taking a callback, it's just going to return a promise. So it returns one of these objects, DB result promise. And then we can pass whatever we're going to do. So we can consume the result with the then callback. So we've just basically moved the callback, if that makes sense. We're still going to have a callback, but we've moved it to the S of the promise. And we can also catch the error. Oh, no, there was some error, right? So now we have two callbacks, which is actually better. Like, who's been writing, like, if error, blah, blah, else, if error, blah, blah, else, if error, blah, 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 else, if error, blah, 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 else? Wouldn't it be nice to be able to write one error handler? Just one, just the one error handler? So we'll get into how that helps us, but it's nice to be able to split those into two pieces. So before we had these, here's the error console log, here's the result console log, and now we have those two. Or we can combine, we can send the two callbacks at once. This is the same thing. It's essentially the same thing. There's one example where it's slightly different, but that's okay. And that is all there is to writing promises, to switching your callback code to promises. Is you just make a request and then you consume the result in this format. To make a more drawn out example, so who has been to McDonald's recently? Like recently enough to know what this thing is, right? So this is their order system now. And what happens is that, yeah, you can see my reflection in there. So what happens is that I have made an order, and I get a receipt there with my number on it, 799. This is as good as a Big Mac meal. I mean, it's not, right? Like if I tried to eat this, it would not be as satisfying as a Big Mac meal, right? But if I hold on to this long enough, and I kind of watch my number 799 on the in progress there, and I watch while it goes to the now serving, well, now my promise of a Big Mac meal has been resolved. And now I don't really care about this promise anymore. I care about the actual Big Mac meal, right? Sorry, a double Big Mac meal. My bad. That is, you know, and I have the fries and the Big Mac and the cup, and we'll get into those and why that's kind of also interesting in terms of promises. But I am now able to take that. So I had the promise of a Big Mac meal. When it resolved, I was then able to access my Big Mac meal and perform my consumption function on said Big Mac meal, right? So when you're thinking of promises, you can think of that receipt. It's not that hard to create a promise. We can especially, I use promise.resolve and promise.reject a lot. There is a promise constructor. And even saying the promise constructor, oh, I realize, actually, I need to put, new. My bad. Excuse me. New promise, resolve some value. So this will resolve with that value. I hate describing the promise constructor because it's like, yeah, the promise constructor, it's pretty simple. You feed it a callback that takes as parameters two other callbacks, resolve and reject, and then you either call the resolve function or the reject function. Simple as that. Doesn't feel terribly simple, but it's not that bad. So you get the resolve and the reject function, and when you call one of them on a value, then the promise is resolved or rejected with that value. So to make a slightly more complicated one, I'm going to make Schrodinger's promise here. So this is, again, this should be new promise. Right? So I'm going to pass it the callback, and it's going to get resolve and reject. And I'm going to basically says, everyone know what Schrodinger's cat is, by the way? I should step back with that. Okay, Schrodinger's cat is a thought experiment about quantum states and how like a thing can be like true or false at the same time, and how like until you observe it, nothing's happened. And so the idea was that like you have this quantum particle, then you put a cat in a box, and after a certain amount of time, the quantum particle will have shifted, and when it does in a certain way, you poison the cat. I don't know why this is an important thing. Why it's like, oh, you don't understand this? Let's kill a cat. Don't worry, it's a fictional cat. But the idea here is that it's like you don't know if it's going to be alive. Like it is both alive and dead until you actually observe it and find out which of those it is. Right? So in this case, what I'm going to do is I'm going to say if math.random, which gives me a number between 0 and almost 1. If it's less than 0.5, then I can say the cat lived. Otherwise, reject the cat died. And so now this is a promise that half the time it'll resolve with the payload of the string the cat lived, and half the time it'll reject with the error payload of the cat died. Okay, so let's make a, don't worry, you'll get to see Ryan Reynolds in a second. So password listener with a delay. Right. Okay, so what I'm going to do is I'm going to use repl.it slash, if I just go, I'm pretty sure it'll try to give me Node.js? Am I not signed up? I'm not signed up. Shoot. Was signed up. repl.it. I am already signed up? Come on. All right. All right. So here's what I'm going to do. Okay. Thank you. Is that I want to make a password checker. And it's going to be something like, you know, const user equals name Joel password Joel, right? We're not going to decrypt this, don't worry. So if I have this, then function check password, username pass. Well, this check password, I mean, it could loop through all my users, but let's just say that it just checked to see, like, oh, let's make this an array. Why not? And I can say const found user equals users.find u.name equals name. Okay. And then so if found user and user.password equals pass, return found user, else return undefined. Pretty simple, right? This, or not check password. We're going to call this authenticate. So we either get a user or we get nothing, right? So let's, if we say console.log authenticate Joel, user is not defined. Found user.password. That's where I went. Okay, name Joel, password Joel. If I say Jeff, it should be undefined. We're okay with that? All right, so this is the synchronous version. Yeah, just straight from the top to the bottom? Okay. So let's say for a moment that we get the requirement, actually, if somebody puts in the wrong password, I want you to delay them by 2 seconds. Don't give it to immediately, give it in 2 seconds. Okay, so we have delays. Can we do delays with synchronous code? Probably not. Probably not a great idea. So what we're going to do is we're going to make function authenticate CB. And we're going to make a callback version of this, which involves, well, we're going to pass in all the parameters we passed into the synchronous version. Name, pass, and then we have some sort of callback. And we're going to say const found user equals, or equals authenticate. Name and pass. So now we have that version. I can just say like, hey, if authenticated, then CB null authenticated. Else, and here's where I get a little, I'm going to set a timeout. I'm going to say wait for 2,000 milliseconds. And then I'm going to CB, not found. So now when I authenticate CB with Joel and error user, if error, console.log error, else console.log user. All right, so I can do this. Happens immediately. I change it to Jeff. Oh, 1 banana, 2 banana, error not found. Okay, so now we put a little of asynchrony in this. So how do we turn this into a promise? Well, because I am still very lazy, I'm going to use the authenticate CB version. So I'm going to say function authenticate promise, name, and password. Am I going to pass it a callback? No, I'm not going to pass it a callback because we're going to return a promise and we can attach callbacks to the promise. So this is good enough. And I'm going to return a new promise with resolve and reject here. And I'm just going to say authenticate CB with name and password and a CB error user. If error, reject error, else resolve user. That's it. That's how we construct a promise. This is how you can turn any callback into a promise, by the way. So if you find yourself with like, oh, I have this library, it only uses callbacks, it's really easy to make a promise version when you're more comfortable with promises. So what I'm going to say here is const auth promise equals authenticate promise. Joel. So now I have that the auth promise is a promise that will resolve with the result of this asynchronous process. And I can say auth promise dot then user console.log user. Pardon me again. Sorry. And then I'm going to say dot catch, and the catch will give me an error. And I will not reject the error. What am I going to do? Console log error. Okay. So now we have that auth promise. We can use a dot then. We can use a dot catch. 1 banana, 2 banana. We're going to kind of see both of these happen. Oh, yeah, here's the promise version. And then here is the error promise. And I'm going to say here, val promise. So yeah, we have the same thing, right? We have kind of the same behavior. We've just moved it out. This promise thing now contains our ability to, like, it allows us to consume a value the same way that .forEach does for arrays, right? Okay, so that is an introduction to the syntax, which brings me to an important question here. Like, why are we doing this? What's the point of bringing in this new mechanism that does the thing that we've already... Was it just splitting up the callbacks? Is that all we got out of this? Well, that is something that we will answer when we come back from coffee break. I'm going to leave that on. Yeah. Okay. Welcome back. I still got sound and stuff, right? Yeah. Cool, 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 cool. Okay. By the way, with these slides, that is a link to another implementation of this. So that's up. So why are we doing this? The one thing that we get out of promises that we don't get out of callbacks is composition. So that takes us out of what we call callback hell. If you have a bunch of callbacks you sort of have to do stuff with, you end up like nesting callbacks and just indenting and indenting and indenting, right? Hi. So, okay. Yes. Did you coffee? Okay, let's go. All right, so if we look at callbacks and promises, they both do a couple of the same things, right? With a callback, you wait for an async process to finish. Promises also let you know when an async process is finished. That's what set timeout does, right? It just lets you know when that amount of time has elapsed, and then when it has, does something, right? And then callbacks also help you handle the result of an async process. Promises let you do that, so right now they're kind of neck and neck. It's just that promises also, they'll also transform the result of an async process, creating a new promise. So we can actually like compose creating new promises as we go. We can chain asynchronous processes. So we can start one and then start the next and have one big process that's like at the end of those. We can wait for multiple async processes to finish really quickly, and we can handle all of our errors in one place. Now, the truth is, sure, you can do all of that with callbacks. There's nothing you can really do with promises that you can't do with callbacks. It's just that for this, you have to be, if you're really good at function composition, you don't mind many nested callbacks, then you do this. But if you're like, I don't, if you are comfortable with like maybe making a map function that takes in a callback and returns a new callback, like takes in a callback and a transformer and returns a new callback that will operate on the transformed value. If you're comfortable with that, you're probably going to be just as comfortable with promises first. So yeah. There's 4 things you can do with a promise, and we're going to talk about those 4 things. And this ability to kind of like put them together like this is a big part of what makes promises awesome. What makes them a lot more readable is that we have these 4 operations, and when you understand these 4 operations, you can manage async processes really, really easily and really, really legibly. So 4 things you can do is you can consume promise, you can transform a promise, you can chain promises, and you can combine promises. So consume, you've already done that. Or at least I've already shown that, right? That is simply, I get a promise, I do a dot then, and in my dot then I perform some side effect. I perform some instruction. I console log. I return the response from an HTTP. If I'm doing AJAX, I get a bunch of things. I make a tweet article with the class tweet for each of them, and I append them to the article's container DOM node, right? I do something. I change the world in some way. In the world of especially functional programming, this is called a side effect. I change the world in some way. All right? So based on a promise, we can take its result and we can change the world in some way. Fair enough? And that looks a lot like this. Some promise dot then res console log handling res error console log handling error. This you've seen. Okay, so we can then, another thing we can do is we can transform. This dot then actually does a little more than just perform a callback. We can transform a promise. The idea is that we can take a promise and create a new promise with a transformed value, just like array.map. What does array.map do? It does iterate through all the elements, and you can do something with it, but doesn't for each do exactly that as well? It returns a new array. One more thing. Returns a new array with those new transformed values, right? So if I, for instance, if I had an array of strings and I could map, that array of strings dot map s bad arrow s dot length, I'd have a new array of numbers, right? Do you guys remember the ground controller Major Tom from week 1? No, you don't. That was like a million years ago. Yeah, I get it. So this new promise will resolve when the original resolves and with a transformed value. Let's take a look at that. We make a request, and then with the result, we transform that, and then we consume the transformed value. The ... there is waiting. So here's the first promise, promise.resolve value. The transform promise, we take equals first promise.then, and with the result, we return res plus transform. It's really important that we return something. So if we return a value from the .then, we create a new promise that resolves with whatever that returned is. So if this takes a couple of seconds, it takes a couple of seconds. Let me go over here real quick. We have the auth promise, right? I can say const name promise equals auth promise dot then user dot name. Let's use Joel here. Name promise dot then val console log name. So what do you expect this to come out with? What's up? Yeah. So what do we expect the name promise to resolve with? Or what do we expect the console log out here? The fact that I called it name promise is a clue. So basically, I take a user and transform it so that, this is shorthand for, right? I don't know if that helps. So this is like a array.map. This does a transformation. So what is the name promise going to resolve with? The name, yeah. Oh, that was the softest of softballs that I love there, y'all. All right. The idea is that this function here, it transforms. It takes one thing and returns another thing, right? And so based on that, we now have a transformed promise, a promise that resolves with a new value. So there's transformed. So for instance, let's say that you do create connects users, insert email Joel, returning star, right? Well, the thing with connects insert, or the returning star rather, is that it never, even though I just inserted one value, this thing is going to return with an array of values, which is kind of a pain. So it's going to create user, but it's going to return me an array with that one created user, with them square boys. I'm just going to keep on doing this for a bit, right? But so what we can do is we can just transform that and say, actually, I want you to take that little array of users and just give me the first one, the 0th one, I should say, the one at the 0 index. And so the get only created user, that's not going to resolve with an array of users. It's going to resolve with one user. Okay. Now, let's talk about chaining. Oh, and also one more thing I wanted to say is that when we talk about the when and with what, this get only created user is going to resolve when create user resolves. That's its when. Its with is with a transformed version of that. So just with that first user. So it's important that we talk about when and with. All right, chaining promises. We can start a new promise after the first one finishes and return that new promise. This might be a situation like, let's say that you create a user and you want to have their ID to create, I don't know, resources on your resource wall, like apparently almost everybody is doing, right? Or you have an order and you want to create order items, but first you have to have that order ID, right? Can you start creating items before you are done creating the order? No, because you're going to need that foreign key, right? So we have to create the order first, and then we can create the order items. Does that make sense to everybody? Cool with that? So I'll show you the operation, but the idea is that this new promise that we get from chaining is going to, if we have one async process that starts another one, we're going to be done when the other one is done, with the result of that second promise. So we make a request, we transform the result and make another request, and then we consume the result of that second request, right? And you can see how it's wait for the first one to finish, and then we can wait for the second one to finish. They have to happen in sequence for when it has to happen in sequence, when we have things where this thing has to finish first before this other thing finishes. So this is kind of an example code. First promise equals async process 1. Second promise equals first promise dot then results return async process 2 result. So this async process 2 is another promise that resolves. And what's really cool about this is that the second promise will be, it'll be based on the, like, whatever async process 2 does. Which means we can use the dot then. We basically use the dot then for 3 things. We use it to consume, transform, and chain. It's really versatile. Sometimes I really wish they had actually broken it out into 3 different functions, like for each and map, and this is kind of like how chickens just kind of have the shoot, and chickens just kind of poop breakfast, which is a weird thing. All right, so let's start entirely. Then result, return async process 2 result. So for instance, here I create a user, insert email. You guys saw this code a moment ago, right? And this is a normal synchronous transformation. I return the user. But what if I have to do a bcrypt hash first? If I have to wait for the hash to happen first, and I'm not sure if you're aware of this, but bcrypt.hash actually does return a promise. And it can take, you guys have been using hash sync, but that is one of those things where it actually like then sits in the main thread and takes a long time. This lets us break that out. So I cannot create a user until I have the hashed password, right? I have to hash the password first, then I can create the user. We're all on board with this idea? So what I do is I start by hashing the password. And then, once I have that password, I can return the product of the second thing. And then, after that, I can even perform another dot then here to get the user 0. So this is how I'm going to ensure that I do things in the right order. All right. The last big operation we can do with promises is that we can combine them with promise.all. The new promise is going to resolve when all the promises resolve and with an array of all their results. And this is meant for combining promises that are not dependent on each other. So this idea is that we can start 2 requests at once. So let's say, for instance, that I wanted to ask Joe to go to 7-Eleven and pick me up some chips, and I asked Chris to get me some coffee, right? Now, does she need to be done for him to start? No. Does he need to be done for her to start? No, these are 2 very separate things. And let's say for a moment, or let's say a better example would be like cream, right? So he can get me the coffee. She gets cream. So I want to eventually combine coffee and cream into like a coffee with cream, right? So I can't really consume coffee with cream until I have the coffee promise resolved and the cream promise resolved. But once they have both resolved, then I can finally have coffee with cream, right? They're not depending on each other, but I have to wait till both are done to actually like start my thing. So this has make request and make simultaneous request, right? Get, send, resolve. I want, here's a better example actually. All right, take a look at this Big Mac meal. I know, someone just got a little hungrier. That's fine. How many things are on this meal? How many things are on this tray that I'm going to consume in some form? There's 3, right? There's the cup, there's the Big Mac, and the fries. Did the Big Mac have to finish before they could start getting my fries? Did the fries have to finish before they could start making my Big Mac? No. So what happened was they have one thing that resolved immediately, which was just here's a cup, right? And then they had the, okay, I'm going to start the fries process where the fries are finished. And if the fries are finished, then I can kind of package them up. So you could think of like thing of fries is batch of fries promise dot, package something up, right? Dot then package something up. And you can think of the Big Mac as this whole like, okay, I have each thing happening in order. I got to get they have this whole process, right? I have to put the patties on. I have to put the things on. I have to do all things, right? But those two processes can be running simultaneously, and whichever gets to the tray first gets to the tray first. But it doesn't really matter which gets to the tray first because I cannot take the tray away. I cannot actually start my meal until all the things are there. So these are a good example of, this would be a promise.all of the cup, the fries, and the burger. And the fact that by the way, the cup is sort of a synchronous, is sort of like synchronous, right? Because it's like, oh, just boom. I don't have to wait on anything. It's just boom, boom. So I can actually put synchronous values into this function we're going to be looking at. So all right, combine results, consume combined results. So here's 2 promises, first promise, second promise. And I have an array of promises. And I can use promise.all. Promise.all takes in an array of promises and gives you one promise that resolves with an array. It resolves when both of these have finished with the result of these. If either of these fails, if either of these reject, this promise rejects. Okay, get user with widgets, user ID. So maybe I'm going to do a get, and I want to get the user with the widget. So I have the promise of like, okay, I'm going to get that user, and then I also have a widgets promise. Did I do something different between those two? Right, ID is user ID. And then I have the widgets promise, which is all the widgets. So I'm getting a query from one table and a query from another table. If I already have the user ID, do I have to get the user object first to then start getting widgets? No, right? Do I need to get the widgets first to start getting the user? No. I can start those 2 processes at the same time. And then when they come back, I combine them using promise.all, user promise, widgets promise. And then I take that array that has user and widgets and make this one combined object that is everything that was true of the user, and also it has a widgets array of all these widgets. I know, that's very ES6-y, that's the last line, but I had to like fit it in, so I was like, I'll make it very ES6-like. So all you need to plan promises is the when and the what. All right, it is 10:21 a.m. Let's do something. So what I'm going to do here is not that. New window. Also maybe one of these. And there we go. Okay. What I'm going to do is I'm going to grab the, I'm going to grab the, where am I here? I feel like I need to take this all the way over here. That's better. I'm going to grab the node skeleton. Not that, that's not a thing. I'm going to grab the github.com/lighthouse labs. Hope that's the right Lighthouse Labs. Nope. I think it's Lighthouse-Labs. Right. I'm going to grab that node skeleton. Okay. Okay, so what I'm going to do is I'm going to take Joe's team's ERD and start creating migrations and seeds given that ERD. Right? And we're going to use promises and constructing promises to make sure things happen in the right order. Fairly simple. Okay. Oh, that's not what I want. I think what I want to do is say file open. Y'all are Lighthouse November something something, and this is the week 4 day 4 lecture. Last night my wife was like, "Are you going into town tomorrow?" And I said, "Yes, I have my favorite lecture." And she said, "Ugh, promises again." All right. Okay. Okay, I'm going to go into my demo. I'm going to go here for a second. I guess I have to do a cp env.example to.env. I don't really care about, I care about this, but not this. I don't think I even care about that. Definitely don't care about that. Pretty sure that's going to be fine. I think I just need the host. Yeah, that's good. And then .env. Need the DB name. Joe's Cafe. All right. And I'm going to say, over in the DB, I have some migrations, right? Create users. Yeah. I'm going to go ahead and delete this migration. Delete. Trash. pSQL. Create database. Joe's Cafe. Cool. All right. That's not what I meant by that at all. You knew it. Okay, so I'm going to say connects migrate make. Oh, let's take a look at migrate make all the schema cause promises. All right, so we're going to make, now generally speaking, I would suggest not making all your schema in one big promise if you're not comfortable with promises. But, as you may have noticed, I'm comfortable with promises. A little too comfortable. A little handsy with them, to be honest. So let's make this happen. Okay. I should have oh, Geo. Yeah. Okay, so what do we have here? What are our dependencies? We have restaurant seems to be a high level. What's it? I like how everything got unique ID. That's fine. I can work with that. I might make them ID just for simplicity's sake. But yeah. So so we have these dependencies. Now, is the restaurant dependent on anything? Anyone see a foreign key in here? No. So we can create restaurants first, yeah? We're all cool with that? So what I'm going to do is I am going to start, where did I end up here? Okay. So I'm going to start here with my migration. It has my connects, has my promise. And what I'm going to do is start with, well, const create restaurants table equals connects.schema dot create table restaurants. And then this takes in that table builder. So I'm going to say here, you know, t.increments, that's just the ID, t.string name, we should probably have a not null here. Is it not null or not nullable? All right. Connects.js. Schema. Oh, come on. Schema builder. Right? Chainable, not nullable. Not nullable. Local URL. Not nullable. Address. I'll leave that as nullable. It could entirely possibly be that you have, like, you know, maybe it's just a food truck that you take to wherever it needs to be, right? It does have to have a phone. And yeah, I'm going to store that as a string. And open time, close time. What are these? Are these time objects? I think you'd have a time object, right? Oh, you have a date time. Oh, table.time. Yeah. T.time. Open time. Not nullable. Actually, let's have it nullable. And if you don't have an open time or close time, you're just always open. Okay. So I have to do this first before I can do anything else. Now, I do have to make one small, like, thing about this. This is technically a promise, but it's actually not a promise. It is a query. I could run a .toSQL on this and see what the SQL is that would create this. So this is not actually, like, when I say, hey, create table, it hasn't actually created the table yet. It's only when I use it like a promise that it actually starts. And just like if you took an array and you said .map, and it was like .map was, if you put in the identity where x equals x, you know, given x, give me that x. If you did a .map over the identity, you would have the exact same array out, right? And be a different array, but with all the same values. So what I can say here is, and this is just to make sure it actually starts now, do it, .then, x is x. So this actually says go. And in fact, we don't really care about what it comes back with, truth be told. Truth be told. Haha, truth be told. I think there is a done. Come on. then pluck, burst, clone, modify, column info, debug. There is a way. Oh, this is going to kill me. Dot return. Yeah, so I'm just going to say dot return. This is the same thing. And that will, because I don't really care what it actually returns with. I just care that it will tell me when it is done. That's all I care about. So I'm going to say dot return. Nothing. All right, so that's create the restaurants table. Now that that is done, I can start doing, and now that that's started at least, I can actually start doing other things. So what are some things? Is there any other? It looks like menu items. Like if I did menu res, that depends on restaurant ID and menu ID. But menu, as you can tell, doesn't actually depend on anything. So I'm going to make that. Create menus table equals connects dot schema dot create. By the way, I'm not passing judgment on any way in this ERD. I'm just getting it done. So don't take the fact that I'm actually doing this as a sign that this is good or bad. I'm not even paying attention to the good or bad of it. That makes sense. Menus. Is it increments or increment? That's going to... Yeah. 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 All right. It's increments. T dot name, T dot string name. Not nullable. T dot string description. I don't care whether it's nullable or not. The name could be descriptive enough after all. T dot time start time. Also don't care if it is T dot time end time. Okay, so let's say that these were just the only two tables and they don't depend on each other. How can I make sure? I want to make sure that this thing is done when all of these are done. Also dot return. So they're two. These are two promises that don't depend on each other, but I want to have one promise that's done when they're both done. So is this consuming, chaining? Is this consuming, transforming, chaining, or combining? Combining, right? So we're going to use. I'm going to say here at the end, I have to return a promise, right? That's just part of the thing. So I'm going to say return promise at all, and create restaurants table. Create menus table. And I'm going to copy this to my exports.down. Now with my down of my migration, I have to undo everything I did up here, right? So I'm going to say, in this case, they don't depend on each other again. So I can say const drop restaurants table equals connects.schema dot drop table restaurants const drop menus table equals connects.schema dot drop table menus. I'm going to say dot then or dot return for both of them. Just again, just to make sure they get going. I want them to start now. And now I can say return again promise.all drop restaurants table. So this particular thing will resolve when both the restaurant tables and the menu table have been completed. Right? I don't care which order they go in. I kind of always assume with promises that I don't know which order they're going to go in. But this will do that. It will finish in that way. So what I can do is I can say connects migrate latest, and it has run that migration. P-SQL Joe's Cafe D. So I have menus, migrations, restaurants, right? I'm going to go back. I'm going to close this. I'm going to go back to my bash here, and I'm going to do the other side, connects, migrate, rollback. And now I have undone that, and it's all just fine. All right, let me create something that's actually required. So we have menu res for menu and restaurant is what happened. All right. Okay. So, oh, let me do one that's just one. Is there anything here with one? Yeah. Let's do orders. Const create orders table equals. Now what has to happen? What's the dependency I have for orders? Oh, okay. Let me just. Right? What's the dependency I have for the orders table? Restaurant ID. So what does that mean in terms of order of creation? What has to be created before I can create orders? Restaurant, right? Now I've already done it, but before I create orders, I need to make sure that it's actually done. So create orders table equals, well, first create restaurants table dot then. So now this will only start after that's done, and from here I can return connects dot schema dot create table orders. And I'm going to start with t dot increments. I'm not going to include everything here. Maybe just t dot string name. Dot not. Hey Sam. Not nullable. And t dot. And I can chain this really easily. I'm going to use the dot references. So t dot integer. Restaurant ID dot references ID, and it's on ID in table restaurants. And I can't really be done with all of these things until this is done. So I'm going to say create orders table. What's nice about, like, okay, strictly speaking, it's weird putting it in a dot all when I was like, wasn't the point of the dot all that we wait till that they can be simultaneous? Yeah, but they don't have to be. So yes, the create restaurants table will always finish before the create orders table finishes. But this just tells me, hey, I need to be done with all of this stuff. Oh, and by the way, how do we express this here? What has to happen before I drop the restaurants table? I have to drop the orders table. So I'm going to say first drop orders table equals connects.schema dot drop table orders dot return. And once that is done, then I can start the drop restaurants table. So I'm just going to say drop restaurants table equals drop orders table dot then dot then And I don't need that return because it's gonna coerce it into a promise anyway. So then I have dropped the restaurants. And of course I'm going to do the same thing here where I drop orders table. This line of code is strictly speaking superfluous. It's useless. Yes. If I don't put the dot then it may try to delete the restaurants table before it deletes the orders table, and that will cause a foreign key thing, and then my entire rollback will fail. So let's see that at work. Okay. There's our migrate latest. P-SQL Joe's Cafe /D. Oh, it didn't mean to do that. Right? Menus, migrations, orders, and restaurants. And it's all been created just wonderfully. If I do a rollback and P-SQL Joe's Cafe and do that again, now we just have the migrations. Okay? So we have managed to express our dependencies in terms of how these are created. If I wanted to create now something that is like menu res const create menu const create menu rest table. Well, what has to be created before I can create the menu res table? And I'm pretty sure it's menus and restaurants. But what has to happen before I can create this? I have to create the menu and restaurant. So that means I have to wait until both of those things are done before I can actually write any of, before I can actually start this process. So let's do that. So I have to wait until promise.all create restaurants table create menus table. I have to wait until both of these things are done. And that's what a promise.all does, right? So even if they start out of sequence or whatever, I can just make sure they're in the right order. Dot then. So when that's done, then I can say connects.schema.create table menu res, yeah, t t.increments, but also t.integer restaurant, that's not how you spell restaurant, id dot references id dot in table restaurants t dot integer menu id dot references id in table menus. And now I'm just going to add this to the list. Okay, well, if I've created that there, what does that mean has to happen on this side when I drop? So what has to happen before I can drop the menu res table? Does any other table, do I have to, is anything depending on menu res? No, so I can just delete it just by itself. That's cool. Const drop menu res table equals connects dot schema dot drop table menu res dot return. Now, nothing is depending on it, but what is it depending on? Menus and restaurants, which means that before I delete either menus or restaurants, I have to delete this first. So let's go back to these. So the drop restaurants table is now not just based on the drop orders table, it's promise.all drop orders table drop menu rest table dot then drop table restaurants. And the drop menus table, now we add our dependency here, drop menu rest table dot then. All right, I'm going to add drop menu rest table here. Again, this makes no difference to the code here. But it does, this is now, the only reason I'm putting this here is for the sake of legibility and clarity. This tells another coder, hey, just so you know, all of these have to be done before this is over with. So that they don't have to read through like all the dependencies, they just know like, okay, I got to this end of the thing, and it does have to be done. Cool, cool, cool. All right, so this has been fun. Let's do a migrate. Connects migrate latest. Connects migrate rollback. Okay, cool. Everything seems to work. Connects migrate latest. So now we can start creating seeds. Now, all I have been concerned with in my migration has been the when, right? That's all I cared about. I can only delete this table when this other table has been dropped. I can only create this table when this other table has been created. So it's been more about making sure that everything was in the right sequence. Now we're going to make sure that everything is in the right sequence. We're also going to care about the payload. I didn't care about payload here. Now I care about payload. So, what are these numbers? Well, a little bit of a, yeah. I'm going to double check to make sure I have the right, yeah, connects, seed, make, all the seed data promises, yo. Okay. All right, so we have this example here. And also, by the way, just so you know, this is kind of a bad example. It's not the worst example. It's a good example of promise.all, but when you do an insert, you can actually insert an array all at once. And that lets SQL do the hard work of like pairing through it, as opposed to JavaScript. So that's another story entirely. But I will have to return a promise from this. That is going to be a thing. Now, I only created menu and restaurants and orders, right? So let's start with that. I have to first create a deletion script. So what am I going to delete first out of these tables? Menu rest, right? That's a good one because it's not, nothing depends on it. So I can say const delete all menu res equals connects menu res dot delete. Okay. Then I can delete all orders equals connects orders dot delete. And I'm going to put a, just for these ones, I'm going to put a dot return after them. Because I don't really care about what the product is yet. I just care that it happened. So to delete all restaurants, is going to be, well, first I have to have deleted all the menu restaurants, right? So delete all menu res dot then connects restaurants dot delete and const delete all, I guess, menus equals, oh, in fact, not just that, I have to do the promise.all because I can't delete all restaurants until all the orders have been deleted as well. So delete all menu rests, orders, dot then. And delete all menus is just okay. And I can just say here, hey, return. In fact, I might want to make one big everything deleted. Yeah, const everything deleted. How am I going to make a promise that resolves when everything has been deleted? Some of which is dependent on each other and some of which is not. What's a good mechanism here? Promise.all. And I'm going to pass it an array with everything. So I'm going to run this seed real quick. Relation users does not exist. What? Oh, there it is. Move to trash. There we are. Okay. So it has done that. Cool, cool, cool. Now I want to start to make things. Right? I want to start creating some restaurants. I want to create at least 2 restaurants. Now, one of the things that I often see is that you guys will put in IDs to these objects, right? Trying to override sort of the natural increments behavior, and so then you still have those IDs, which is pretty cool, but also not so cool, because what ends up happening is that then you don't let the IDs change, sort of recreating everything from scratch. So what I'm going to do is I'm going to show you how to do this where you can just like, hey, you just let them get created and then look at the IDs when you're done. So const create some restaurants equals, start with everything deleted, dot then. And I'm going to start the const all created promise here. Everything created. Okay. And here we're going to say, we're going to return connects restaurants dot insert. And what do we need in our insert? What do we end up with saying here? We end up saying that we need a name, a local URL, a phone. That's all we really need, right? Name, logo, URL, phone. So name, Los Pollos Hermanos. Logo URL, images google.com, Los Pollos Hermanos. What did we say? The logo URL, right? You all know what Los Pollos Hermanos is from, right? Are we all clear? Breaking Bad? Anyone? All right, doesn't matter. Phone is 555-5555. And we can create one that's fine. That's a thing, I suppose. Just creating one thing. So now, when we run this seed, we've cleared everything out. We have that. If I go, I'm going to make this one my p-SQL. p-SQL Joe's Cafe. Select star from restaurants. So we have Los Pollos Hermanos there. Okay. I guess this is where I'm looking here. All right, what's another thing we need to create? We have 4 tables, so just we can pick something out of restaurants, menu res, menus, orders. What can be created now based on what we've already created? Yeah, we can create menus. So const menus created equals, or yeah, create some. So this is like menu items, right? Or is this like a whole menu? Either way. So here we're going to say connects menus dot insert name. Like, how crazy would we go with that? Just name and description, maybe. Name, good chicken. Description. Surprisingly addictive. Okay. It's funny because math. All right, let's create some menus. Okay. I'm going to run that seed again. So if I run the select star from restaurants again, I'm going to see that Los Pollos Hermanos is now 2. Right? So it's recreated this. And I'm also going to see select star from menus. But it's okay. It's okay that it's 2. I didn't hard code that one ID into my what's it, so we're going to be fine there. What I'm going to do is, okay, I now want to be able to create a menu res that links these 2. And this might be where I end up stopping on account of it's already 11. Okay, so here's my big payoff here. I want to be able to get one restaurant ID and one menu item ID. So const create some menu res equals. Well, I have to wait until I've created some restaurants. So promise.all create some restaurants. Create some menus. Right? Then. Now, I said that a promise.all, it'll resolve when those 2 have resolved. But what will it resolve with? Do you guys remember? It'll be an array of the results. So now I have restaurants and menus. Not only do I have restaurants and menus, I can break this down even further and say I have Los Pollos Hermanos, and I have good chicken. This is array destructuring. It lets me like kind of get to the certain items in that array. So now I have Los Pollos Hermanos, and I have good chicken. Now I want to wait till menu res is done. I'm going to say return. I might even take out the return here. I'm going to say connects menu res dot insert Um, let's make this an array as if we had more options. But the restaurant, it needs a restaurant ID and a menu ID, right? So what's the restaurant ID going to be? Los Pollos Hermanos.id. And the menu ID is going to be goodchicken.id. All right. You'll notice this is kind of, you know, not entirely as bright as the rest of this, which means we just have to add it here. So create some menu res. And now we can do, oh, this is a problem because problem set all that then. Not sure why this is angry. Has undefined is not a function at 2511. Let's just take a moment here and console log that we have the right stuff, right? That we have restaurants and menus. Log, create some menu res, restaurants, menus. Okay. Oh, you know what I forgot to do? Dot returning. There we go. The dot returning basically says like, hey, I also want you to return the what was created. This is a connects thing. Sorry about that. Let me. Oh. Okay. Try this again. And now this is mad because, oh, Los Pollos Hermanos is not defined. Yeah, fair enough. Los Pollos Hermanos. Good chicken. All right, ran one seed file. And now I can go back to my pSQL. I can say select star from, or select r.star m.star from restaurants r join menu res mr on r.id equals mr.restaurant id join menus m on m.id equals mr.menu id. And now we have that Los Pollos Hermanos, blah, 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 has this particular menu item. And we have built our relationship. And so when we read this, we can read this as, hey, I have to wait until I have created some restaurants and created some menus. And with the product of that, then I can use this. Another note to point out is, by the way, if a promise is already resolved, you can use the dot then and get it to use it. You don't actually have to like worry about like, oh, what if I don't want to call an event on something that's already passed? Doesn't matter. Even if it's already passed, you'll still be able to get the value out of it. It's pretty good. And then this is just everything is done. Are there any questions? Yes.
Is there any potential problems doing all your migrations under one migration?
Well, yeah, generally speaking.
Okay.
You know, when you do your initial ones, that's kind of fine. But it's generally a good idea to kind of space them out. But I wanted to use this as a great example to show how you could combine them and what you could do with them. And once you understand how to use those 4 techniques, consume, transform, chain, and combine, you'll be able to handle a lot of async processes really easily. And that's just a pain to do in callback versions. Okay. Well, if there are no more questions, and also over time, I'll have my notes out and I'll talk to you guys later.